Welcome everyone to our first in-person Linnean meeting since the pandemic. I'm really happy to see how many people are here today. Really happy. And welcome to everyone who is on Zoom. I hope that you are getting a good feed. We are making plans to record this just in case there is some technical difficulty with the Zoom feed. I just want to, apart from saying how happy we are to see everyone, I just want to remind everyone that dues are due now-ish. Well, last month-ish. And so please try to remember to pay them. It's easily done online. All of the communications from us have a nice link in them to the online payment, and you can also still pay by check if you prefer. Our fall season has started and is going very well. We have, as of today, we have, I think, 17 more field trips for the rest of the year. A big reminder about our homecoming on September 21st this year. It's at the Summit Rock in Central Park, and the rain date is a week later, September 28th, in case we need it. Next month's meeting. So I'm the president tonight. We have, as you know, we're still looking for a president of the society. And please, if you feel like this is something that you're interested in, please let us know. Any one of us on the board, we'd be very happy to hear from you. Richard Davis is our president for next month in October. But the other important thing about October is that our meeting in October will be here and Zoom on October 14th, which is a Wednesday, not a Tuesday, just this one time. We'll make announcements about that in any future communications, and it will also be on the website. I'd like to also welcome our new members. And I'm going to call the names. If anyone is here, if any of these new members are here, please identify yourself so that we can welcome you in person. Aubrey Almanza, Timothy Beard, Z. Beard, Benjamin Bolduck, Elizabeth Braswell, Stephen Chenault, Teresa Colazzo, Christine Conley, Bob Curtis, Peter Drummond, Richard Dundee, Rory Edge, Pepper Evans, Andrea Fondulas, Brian Fox, Eric Frawley, Christopher John, Anna Kesbach, Isaac Kress, Hilly Kushner, Wang Mai, Nina Molina, Lisa Nastor, Eve Oppenheim. Yes, all of these are new members. This is a great long list. Diego Orlansky, Catherine Pan Giordano, Michael Posinski, Sandra Power, David Scorbati, Nancy Taubenslag, Marta Torres Quinones, Denise Vachia, and Liam Wager. Yay. I think that is probably all of our pre-meeting business. Is that correct? Good. So now I'm going to introduce to you our speaker, Dr. Erik Katovich. Dr. Katovich is an assistant professor of environmental and natural resource economics at the University of Connecticut. He received his PhD from the University of Wisconsin-Madison and completed a postdoc at the University of Geneva in Switzerland. Prior to his PhD, he was a Fulbright Scholar in São Paulo, Brazil. Note that I didn't call the name of the university. He is originally from Minnesota. Erik's research focuses on understanding how we manage natural resources and extractive industries to promote sustainable economic development. He is also an enthusiastic lifelong birder with experience birding throughout the US, South America, and Europe. The title of his talk is How Do Wind Turbines and Fracking Affect Birds? Please welcome Erik.
Wonderful. Thank you so much for the invitation to join you tonight. I'm understanding that I'm the first one to speak in person, coming back in person, so that's a great honor. I think it's wonderful to have in-person events, and it's really exciting to join you all here. I also had the pleasure to meet several of you this morning. I went on one of the bird walks, which saw all sorts of things, all sorts of warblers and nice Central Park birds. So that was really fun introduction to the group. And I think it's just thrilling that there's so much participation. Just the bird walk this morning with, I don't know, probably 50 people there joining in is amazing. So it's exciting to get to know your group and exciting to talk about my research, which I think this is based on a paper that I wrote. It was published in late 2023 in the journal called Environmental Science and Technology. Has a different title than this, a little more technical than this title. But the topic continues to be extremely relevant and timely because of news and events that I'll talk about, right? So wind continues to remain a controversial topic. Fracking is as big or bigger than ever. And so these issues continue to be really relevant for us as a society to think about. So just a bit about myself. Julian already gave a nice introduction, but I'm an assistant professor at the University of Connecticut. I'm from Minnesota originally, and I really love birds. And so my research typically focuses more on economic outcomes. So I look at things like effects on people's wages and on companies and how governments use their resources and things like that. This project was more of a passion project, focusing on birds because I've always really loved birds, and I grew up as a birder. I've had the opportunity to bird in a variety of places around the world, including in Brazil, which is a great place, a very fun place. You can see more birds there in a day than in a months of birding effort in Minnesota. So these are a few of the pictures I've taken in Brazil's Atlantic rainforest. I always really liked the black goggled tanager. I like his little expression there in the top right. Okay, so a bit of the origins about this project. It started out with reading a newspaper story in the Minneapolis Star-Tribune newspaper about the Christmas bird count. And I had never known about the Christmas bird count before, but the way they were describing it in the newspaper started some process in my brain realizing that it was actually kind of a perfect data set to answer a question I'd been seeing bouncing around in the media about this controversial issue of how might wind turbines affect birds, right? We see a lot of claims and a lot of fear-mongering and a lot of concerns that wind turbines might have killing a lot of birds and causing, significant numbers of bird collision deaths and things like this. And so I thought, okay, we have this big debate going on in the media, and the Christmas bird count is set up in a way that, based on the citizen science data, I'll talk more about the specific data set, is collected systematically with the same methodology in the same locations year after year for a long period of time. And as an economist, I immediately started thinking, well, this plus the methods that we typically use, the statistical analyses that we use, could help me provide some empirical evidence to contribute to this debate we're seeing about how do wind turbines affect birds. So why does this issue matter? But because both wind turbines and another major land use environmental impact, which is oil and gas extraction through fracking, both of these activities have increased drastically in the United States over the last 20 years, okay? So for example, shale gas, which shale is basically the type of geological formation where you do fracking, which is a specific technology for extracting oil and gas. So this has expanded about 20-fold since 2007, when that technology really took off. We don't see much in New York, but Western Pennsylvania, actually Western New York also has quite a bit of fracking, and Western Pennsylvania is a big hotspot. Places like North Dakota, Wyoming, Texas are really big booming areas for oil and gas fracking, okay? Wind has also expanded drastically over this time period. So a 48-fold increase, and basically there were very few wind turbines in 2000, and we've seen a huge increase in this land use since then. You can see in these pictures, I mean, both of these are pretty extreme examples. It's often not this dense, but these are example pictures of how both wind and oil and gas fracking can affect landscapes, especially when done at the type of scale they're done in some places. So this graph is basically to show that the US over this time period has experienced a pretty drastic energy transition. Part of this transition is towards renewables, so that black bar that is starting to grow quickly at the end is renewables. That's wind and solar combined. But we know wind again is a big part of that. But the real energy transition the US has seen has been a transition from coal, that sort of beige line on top. So coal declining and being replaced with natural gas, which is one of the main outputs from fracking. So we have seen an energy transition. It's just within fossil fuels from one type to another, from a very dirty fossil fuel, coal, to a less dirty but still fossil fuel, which is gas. And renewables are starting to pick up. So this is a big transformation that's happened in the US over the last 20 years or so. Why does this matter? Because different types of energy sources have radically different impacts, both for human health and for the environment, okay? So on the left here, we can see the death rate basically from different types of energy sources. This is combining mostly the effects of local air pollution, plus maybe some accidents and things like that. So you can see that coal is the largest contributor to deaths, largely because of really devastating effects on local air pollution. So this can be mitigated with filtering and things like that, but air pollution is really bad from coal, right? So if we can shift from coal to natural gas, you can see that results in a very significant improvement in local air pollution and a significant improvement in human health conditions from that transition. And of course, wind, hydropower, things like this have significantly lower impacts. I don't know what the deaths from wind and solar are coming from, maybe an accident at some point, but those are pretty negligible, right? If we look at the graph on the right, this is showing one type of environmental impact, which is carbon emissions, which contribute to global climate change. Of course, there's a lot of other environmental impacts. There's pollution, there's effects on wildlife, there's other things. But in terms of carbon emissions, we can again see that transition from coal to gas is a positive transition, right? So there's about 40% of the coal emissions from gas. So that's a much cleaner energy source, but still large contributor to carbon emissions compared to renewables like wind or solar, okay? Another thing that's not shown here is that we're learning more and more. New science is showing that fracking, natural gas is associated with far more methane emissions than we knew were occurring. And methane contributes approximately 80 times more to global warming than carbon does, and takes a long time to sort of lose that effect in the atmosphere. So methane, this is probably understating the true carbon equivalent effects of the natural gas cycle. So in any case, we can see here that there's relative sort of impacts from different energy sources. As a society, we choose which of these energy sources we rely on, and they have different impacts in terms of human health, climate change, and also, as I'll talk about today, in terms of wildlife impacts. Okay, so despite the fact that there's these two energy sources, right? So we're getting a lot of our energy from fracking, oil and gas, and we're getting a growing amount of our energy from wind. The media overwhelmingly focuses on connections between risks to birds, damages to birds, and wind, right? So this is drawing about media stories from major newspapers in the US that are mentioning birds alongside wind turbines and risks and damages and things like that. And the same with fracking. We can see that overwhelmingly the media is talking a lot about wind turbines and birds, okay? And of course, it's really easy nowadays to go online and just grab some news stories, right? About, Trump, for example, talking about, wind turbines are a huge risk to birds. Offshore now they're talking about whales. That's a separate literature, which I won't speak to directly today. So there's a lot of concerns being raised, and there's very little concerns being raised in the media about connections between oil and gas extraction and impacts on wildlife. So today I'll show empirical evidence looking comparatively at which of these impacts wildlife more. Okay. So, the media is all focused on impacts of wind turbines on birds. Should we be concerned as people who care about wildlife? Okay. So there are some studies on this literature, and it turns out that when you kind of look under the hood and dig into the methodology of these studies, they're doing the best they can, but it's kind of a lot of wild guesses, okay, for all of this. So these could all be off by an order of magnitude either direction, right? They're kind of wild guesses. So there's a study from 2013. Now, you have to remember that there's been a lot of wind turbines added since 2013, okay? So these impacts are potentially lower than what we would be seeing today. So an estimate of maybe 140,000 to maybe 700,000 bird impact deaths per year from wind turbines in 2013. But that's really just counting the birds found under a few turbines and kind of extrapolating to the number of turbines in the country. So it's really a wild guess. We also have educated guesses about impacts of other major impacts on birds, which, again, the largest are building impacts, collisions from buildings, which might be 600 million, and from cats, which might be up to 1 billion. And this is just in the US, right? So again, when you dig into there's not a lot, to be fair, going into sort of where these exact numbers are coming from, but they're educated sort of estimates based on data available at the time. And even if these are off by a factor of 10 for either of these, we can see that the wind turbines are nowhere near the impacts from, humans impose, clearly a lot of impacts on our environment, a lot of effects on birds, and it's unlikely that wind turbines are amongst the major factors in terms of bird collision deaths. So how do I contribute to this literature? Like I said, pretty much all of these studies are based on case studies of looking at bird collisions around specific wind turbines and maybe extrapolating that to other places. I am going to take a different approach. I'm going to use a nationally representative data set, a systematic collection of bird population counts through citizen science, which is the Christmas bird count. And I'm going to use that plus statistical methods and something called econometrics, which is basically trying to get at the causal effect of something on some other outcome. And so I'm going to try to understand the causal effect of this expansion of wind turbines over time, the expansion of oil and gas fracking over time. How has that affected birds on a population level? So looking at the number of birds in a specific place and the biodiversity, the species counts of birds in a specific place over time. So really quickly, so there are a lot of people who have studied these topics using a variety of methods. Wind energy, the first thing I'll preface with this is that wind energy, solar, things like this are key inputs into an energy transition away from fossil fuels, which is necessary to avert the worst damages of climate change, which will also affect wildlife in a variety of ways, right? So we always have to think about weighing relative costs and benefits. All human activities in the environment have costs. So we have to weigh the magnitudes of the effects relative to alternatives. So as long as society wants energy to power our lights and our factories and our cars and things like that, as long as we want to consume energy, and we're consuming more and more, we have things like AI data centers now and, more and more things demanding energy. As long as humans want energy, we have to think where we're going to get it from, and there's always going to be some impact. We have to weigh relative costs and benefits, right? So wind turbines have been shown, that there's some people have shown bird avoidance behaviors, and so maybe birds moving from the immediate area to a few hundred meters away from wind turbines, especially during construction where there's trucks and there's people moving around. There's collision risks are shown to be highest for migrant species that might be just moving through, whereas locals might, be more used to the wind turbine being there. There's been evidence showing, again, so birds might kind of move away and avoid, wind turbines. And also, of course, wind is not just wind. There's transmission lines that have to connect it, and there's things like that. And so the impacts from that might not be immediately around a turbine, but there's also all the grid that you need to connect out. That, of course, could impose additional costs on birds. So fracking is another, activity that can have significant environmental impacts, right? So fracking generates consistent air and water pollution, as well as light and noise pollution. So, again, if you think about a wind turbine, once it's installed, it's kind of spinning there, and the spinning part might be the largest factor in terms of burn collisions, but it's not generating smoke, it's not generating air pollution, water pollution, or major noise, or it turns out with fracking, one of the things most pointed to is truck traffic. So a lot of fracking pads are not connected by a pipeline. They're connected by trucks moving back and forth carrying the oil and gas output, right? So it turns out that constant daily truck traffic can put dust out to 300 meters into nearby fields consistently day after day. Fracking pads usually run really bright lights at night. They're often flaring the oil, the gas that's coming out, that if they're not able to pipe it away or contain it, they're flaring it off in an extremely hot plume of flame. So there's a variety of environmental impacts. There's, of course, they're pumping large amounts of water and then injecting it down, plus a lot of chemicals, injecting it down into the ground to fracture the rock to pump out the oil and gas. And so there's a lot of surface water disturbances as well. So I think a picture that illustrates the scale of global impacts from the fracking industry here is an image from space, okay? And the lights are sort of processed to make this more visual contrast, but I think what's important here is the relative order of luminosity. If you look down at the bottom left, that's like Los Angeles, like a giant city, or if you look up where New York is, right? So giant cities are sort of medium level brightness. Think of all our lights that we have, and that's medium level here compared to the really powerful brightness that you're seeing in fracking fields, okay? So the really bright spots are Western North Dakota, which is major fracking, up in the Alberta tar sands, the Texias, the Permian Basin in Texas. You can see kind of a little bit in Pennsylvania, right? So the brightest spots on our planet, we're literally lighting the planet on fire with flaring from fracking, and it's visible from space, and it vastly outshines the luminosity of our brightest cities. So I think that shows a bit of the environmental, the impacts. Okay, so what do I do? What is my research question? So I'm going to try to understand, again, we've had these two technologies that have expanded rapidly across landscapes over this 20-year period. Lots of wind turbine construction, lots of fracking construction. How did this affect bird populations and bird biodiversity? I'm going to use a data set called the Christmas bird count, collected since a long time ago by the Audubon Society. And basically what this map is showing, each of these sort of little red circles is a Christmas bird circle, okay? Within that circle, every year, a team of volunteers, citizen scientists, go out and they use a systematic methodology led by sort of an experienced leader. They split the circle up into segments. Many of you might have participated in these. I never have, but it would be super cool to participate. And they collect on a single day in December, collecting up all of the number of each bird species that they see. And usefully, importantly, they use the exact same methodology year after year after year. So if you see changes in birds happening within a circle over time, you could, using statistical methods, attribute those changes to things that happened in that circle, including, for example, the construction of wind turbines or the construction of oil and gas wells, okay? So if you take the data from the Christmas bird count and you just plot it, so first of all, this top one is showing the number of birds. So again, they're winter birds. Okay, so this is birds in sometime in December. It would be a different distribution if you showed like June birds or something like that, right? So we can see that in the winter, there's birds maybe are in the center and the southern parts of the country. That's where the largest bird abundance is, right? And then if we look at species in terms of biodiversity in the winter, we can see, and this is pretty predictable, along the coasts and more in the south, you see more bird biodiversity. So, for example, I'm from Minnesota. It's dark on this map. It's sort of, pretty barren in the winter. There are some birds, right? But you're not, so if you can see here on the range, maybe there's about 50 species available in the winter to see. If you're down somewhere there in Texas or something, you might be seeing 200 or 250 plus birds in the winter. So, okay, there's distribution in bird abundance over time. I do want to defend Minnesota. There are cool birds. There's cool winter birds in Minnesota. These are pictures my dad and I have taken. There's a really neat place called the Sax-Zim Bog way up near the Canadian border. You can see all these cool, the great gray owls and all this nice stuff. So it is fun, but it's a different type of birding, of course, a bit more chilly than, So I think these are things you could see, I guess, there in the Christmas bird count. Okay, so we have data on the number of birds seen over time, and all the different species. I'm going to combine that with data on all of the fracking wells built since 2000 and all of the wind turbines built since 2000, okay? So we can see, if you remember that map of where the fracking lights are brightest, that's where the wells are, of course. So we can see Western North Dakota, big parts of, Texas, Wyoming, Pennsylvania. Those are really the hubs of the fracking industry. I think it's an invisible industry for a lot of people here. We don't see it directly if you're in New York, right? But if you go out there, these impacts are very clear. Okay, wind also has quite interesting distribution, right? So it's really big in the Midwest and in the center of the country. That's where you have a lot of abundant wind resources and a lot of abundant land. So that, Iowa, for example, is a real booming area of the wind industry. West Texas is a huge booming area of the wind industry. This one on the right is just showing that the number of bird circles over time that have inside that circle either fracking wells or wind turbines has been growing steadily over time. So, approximately maybe now about 15% have like a wind turbine within the circle. Okay. So what is my methodology? I'm going to use a statistical method called difference in differences. I'm going to compare how changes, in bird counts over time can be attributed to the construction at different points in time of either wind turbines or fracking wells within a circle. Okay, so if you think here, there's like a bird circle, and at some point in time, you might see that a wind turbine is constructed there. And I'm going to look at the number of birds counted before that and after that. And so if you could imagine if the bird population afterwards collapses, well, maybe that's attributable to the construction of the wind turbines. To do that in a credible way, you need to use a variety of methods and approaches and control for important things. So, for example, I'm going to control for, I'm going to be able to basically use some statistical techniques to take out all of the effects that are sort of fixed at a circle over time. So everything that's just like, you're always going to see more birds maybe in December in Louisiana than you are in Minnesota, right? And so I can take out those factors that are just fixed over time. I can also take out factors that affect everyone in a year. So if there's a really bad year, like a super cold winter or something, and every bird across the country, there's less birds spotted that year, I can take out those national effects. And then another nice feature, an important feature of the Christmas bird count is that you can control for all these conditions on the day of the count. So the weather, the number of counters available, that's super important because you're always going to see more birds in a place with 100 counters versus a place with 5 counters, right? So I can adjust for that. Controlling for all these weather variables and things like that. So one question I often get is, why don't you use a data set like eBird instead? Okay, so there's trade-offs when thinking about what type of data set is best here. So eBird is much richer, right? We have data on many, many more locations, basically everywhere. And we have like daily frequent updating of that data set, right? So for example, today there was a filing in Central Park for the Linnaean Society eBird report, right? So there's way more data from eBird. An issue with eBird is that it's not collected in a systematic way as the Christmas bird count is, right? So you could imagine that if people hear about some really cool bird, they might all go there and report it. And all of a sudden, it looks like that bird is super abundant, right? Or you could imagine that a fracking well is built and now people don't like birding there because they don't like being around the fracking well. They stop reporting on eBird. So it could look like bird abundance fell, but actually it didn't. It's just people stopped going there. Right? So the Christmas bird count avoids all of that stuff because it's collected in a systematic way using the same methodology over time. So that's the advantage. The trade-off is you get this one snapshot per year in December. So it's a much less rich data set that is collected systematically. Both have huge value. People use eBird for a bunch of research. There's really cool research being done with eBird, but I didn't use it yet. Okay, so turning to some of my results, I'll explain how to interpret these graphs. Okay, so first of all, these graphs are looking at the effect of the introduction of fracking oil and gas wells in a bird circle. So what is the effect of building fracking wells in a bird circle? How do you interpret this? So if we focus first on this top one, the one that says total, okay? So if we focus on that one, the way you can interpret it is if that red bar intersects with the 0 axis, that means that there's no statistically measurable effect of fracking wells on the bird population count. If that line is to the left, so it's a negative effect, and it doesn't intersect with the 0 line, that means that there is a statistical negative effect of the fracking wells on subsequent bird population counts, okay? So what we can see here is that the total effect is yes, after fracking wells are built, there's a statistical reduction in the number of birds seen in subsequent bird counts, okay? Even controlling for all of those factors that I just mentioned, okay? And if we break it down by different bird characteristics, we can see that some types of birds are affected more than others. So on the bottom, again, we have the migrants. So migrant birds are particularly negatively affected by the fracking, okay? Also non-urban birds, that makes sense. Maybe urban birds like pigeons and stuff like that, right? They're more used to humans, they're less affected, whereas non-urban birds are really, upset by this human activity. We can see grassland shrubland. I think the grassland shrubland has the largest impact because that's mostly where fracking is being developed, is grassland areas, okay? If we look on the right, this is effect on species count, not bird abundance. And we can see there's not really too much of an effect. There's no really statistical effect on species count. Now, I would point out that I'm using like a really strict measure of species count, which is just the number of species counted, okay? So that means that to lose a species there, you would have to see 0 of them. Even if you saw 1, it would count. So you could almost have a species wiped out or completely exited that area. And as long as there's 1, it won't show up as a loss here, right? So there's other ways to measure biodiversity. Some of you might be ecologists and have preferred methods. This is like the simplest possible method, but it's like kind of the most extreme version of simple species count. If we look instead at wind turbine construction, we can see that all of these blue lines are intersecting with that 0 line. Okay, so what that means is that after wind turbines are built, there is no statistically measurable effect on the number of birds or the species of birds counted. And that holds true across all of these different categories of birds. Okay, so fracking, again, for the species, the bird abundance count, you see these negative effects. And using the same methodology and the same data set, you see no measurable effects of the wind turbine construction on bird population counts. I'll talk later about more limitations, but this does not mean that birds are not killed by wind turbines. They are. If you go out below wind turbines, you will occasionally find bird collision deaths, okay? So what this means is it doesn't mean that there's no deaths of birds. It just means that it's not large enough that it's reducing a population count. Okay? That doesn't mean we shouldn't be concerned about minimizing wildlife impacts, but there's no measurable effect in the data. A separate way to do it is instead of just comparing before and after turbines are built or fracking wells are drilled, you can look at the number of turbines or the number of wells within a circle. So this is like how intense is that activity. So the results are super similar, but basically the takeaway here is that, again, the effects of fracking are negative. So reducing bird population counts and even a little bit species counts now. If you look at the intensity of fracking activity, this matters because, in the previous definition, if you have 1 fracking well, that circle is considered as treated by fracking. Here, it's looking at the intensity. And so if you have an area with a lot of fracking, you're now seeing also significant reductions, not only in populations, but in bird species counts. Okay. If we look at wind, again, there's nothing. There's, so no matter how many wind turbines, you're not seeing significant reductions in the bird population counts. A little calculation would say that a 10% increase in fracking wells, well, anyway, I think the more understandable one, 3.6 birds, fewer birds seen per fracking well drilled. That's only 1 day in December, right? So if you think about what are those effects over the year is a lot more than just 3.6 birds. Okay. What if we're interested in taxonomic orders instead of bird characteristics? So you can do the exact same analysis. You just split it up by order of birds instead of grassland, shrubland, that kind of thing. Okay, so the total effect is the same exact thing, right? But now we can see this might be a little small. So the top one is one that's super of interest and of concern, which is exopitriforms, right? So this is like hawks, eagles, vultures. Okay, so exopitriforms are negatively affected by fracking, and again, are not negatively affected in terms of population counts by the wind turbines. Okay, so this is a group that is always mentioned in terms of concerns about wind turbine collision deaths, mostly because they're super charismatic birds. So we see, there are collision deaths from mostly golden eagles is the main issue. A little bit bald eagles, there's less of that, but that does happen. And those are super charismatic and important birds, right? And so that matters a lot, and those deaths happen, but you're not seeing a statistically significant reduction in the population count, even amongst exopitriforms. So if we focus here, where are the largest impacts of fracking happening? The largest effect is on strigiforms, right? So this is owls. So I think this makes sense. Owls are particularly sensitive to human impacts, right? They're kind of shy birds. They might be particularly the ones that move away or avoid areas where human activity is happening a lot. But we're also seeing, negative effects on a variety of different types of bird categories. And again, really not seeing any effects of the wind turbines. Another way to look at this is trying to understand how do effects evolve over time around the construction of fracking wells or wind turbines. So again, I'll explain how to interpret these graphs. So if you just focus on one of them, okay, the dotted vertical line is the year that fracking wells were first built within a bird circle. So the little red lines before that are indicating, was there a difference between places that have fracking and don't have fracking before those turbines were constructed versus after. So we can see that in the pre-periods, there was no difference. There was no statistical difference. The places with and without turbines or without fracking wells were evolving in the exact same way. After the fracking wells were built, now we see a significant reduction in the number of birds being seen. I think, so this is the grassland, non-urban. So we can see that there's these sustained reductions in birds. It's not just during the construction phase, it's a sustained reduction over time, largely because, the environmental impacts of fracking are not just the drilling stage, but there's constant operations. Like I said, there's constantly trucks going back and forth. There's flaring of the gas. There's bright night lights. There's loud noises. There's surface water disturbances. And that's sustained over the entire lifespan of an oil and gas field. Okay. Again, if we look at wind, there are no effects at any point in time from the wind turbines, even during the construction phase. There's no measurable impacts. Okay. So a final question is, well, what happens if we look, are effects different if we look inside and outside of important bird areas, right? So we know that there's certain places that are like sensitive bird habitats. They might be migratory staging grounds. They might be breeding grounds. They might be overwintering areas, which might be particularly relevant for the Christmas bird count. So the National Audubon Society has a map of what they consider important bird areas. I don't know exactly, whatever their definition is, I just take their definition of that, which are these green areas. We can see that some of these black dots are the bird circles. Some of these black dots are bird censuses conducted within important bird areas and outside. So maybe it's the case that you might expect that environmental impacts might be larger on birds inside areas where birds are like, areas that are particularly important to birds, right? So, okay, it's kind of a lot to look at, but what we can see here, if we focus on this one on the left, the red lines are places inside the important bird areas, and the brown are places outside the important bird areas. What we can see is that it gets noisier because I'm splitting the sample, and now there's more sort of smaller sample, more statistical imprecision. But we can see that in general, the effects are more negative for places that are where fracking is built inside important bird areas. Okay, and in particular, you also now pick up negative effects on species counts, on biodiversity, for places that are built inside important bird areas. So where, in particularly vulnerable or important bird habitats, that's where you're seeing the most negative effects of fracking happening. And again, even when I split up the wind turbines inside and outside of these areas, I'm not measuring any effects on the bird population or the species counts. Okay, so what are some of the key takeaways from all of that? It's a little overwhelming, but I think that overall, there's a pretty consistent story that runs through all those results, which is that fracking significantly reduces bird population counts, right? So bird abundance. And in some cases, for example, inside important bird areas, it's also reducing bird species counts, bird biodiversity. Wind turbines, on the other hand, there's no measurable effect of wind turbines on bird populations or species abundance, okay? Now, there's some caveats, right, with this, like all studies have limitations. Like I mentioned, I'm not able, because these data are collected at a circle level, a circle is like 10 miles diameter, this is talking about effects on a measurable population level. It's not able to pick up a few bird deaths, which we know happen under wind turbines, right? So it's not able to pick up those very small impacts. So that's, and it's also, for example, it's not able to say, it's not saying that fracking is killing all those birds. It could be that they're simply moving over to the areas nearby a fracking area that, they could just be avoidance behaviors. I'm not able to distinguish those two. Okay. Nonetheless, so, okay, I think I've showed that again, using the same methodology and the same data, right? That because it's the same methodology and the same data, we can, I think, compare these two types of impacts and conclude that fracking has much larger negative effects on bird populations than wind turbines. And because we talked about if we need energy as a society, we need to choose where we get it from. All types of energy extraction and collection have impacts. We need to think about relative magnitudes of impacts from these different choices we're making about where we're getting our energy from. We can also, of course, try to minimize wildlife impacts no matter what, right? So there's a whole variety of literature looking at how can we minimize the impacts of wind turbines, and there's a variety of things. A lot of these are like a single case study, like they tried it once and maybe it worked. So for example, there's pretty well known this case about like painting one of the wind turbine blades black. This worked really well in like 1 or 2 cases. And I haven't seen evidence of it being scaled up to sort of test it on a more systematic level. Maybe some of you might know about this better than me. But it worked really well in some specific wind projects. There's a whole variety of other things you can do. So like, you could be careful about where you're siting. One issue is that often you want to put a wind turbine like right at the top of a hill or somewhere where the wind is the best. That's often right where birds are migrating through, for example. So in Norway, where they have a lot of wind energy, they do a lot of planning around birds to think about, they're doing a lot of offshore wind in Norway, and they're specifically thinking about where are offshore birds migrating and moving, and they're taking that into account when thinking about placement of wind turbines. So that's, of course, something you could think about. There's looking at using things like birdcast and making sure that maybe on nights when a ton of birds are coming through, you could turn on or you could turn off the wind turbines or something like that. You could use acoustic emitters, which might deter birds or warn them that they're getting close to something. So yeah, there's a variety of things. There's active research going on in all of these things. And of course, we should be interested in efforts to reduce impacts from wind turbines, especially if we think we really want to ramp up this energy source as part of the energy transition away from fossil fuels, right? Okay. Fracking, of course, has these large negative impacts on birds. And there's a variety of things we could do. So a direct implication of this research, of course, is that you could avoid drilling inside really critical bird habitats, okay? So, the profit motives behind fracking are large, right? And it's difficult to get someone not to drill in a place if there's a lot of oil and gas there. Nonetheless, it is ultimately a choice. Most oil and gas fracking happens on federal lands, which are leased from the federal government, which belong to the public of the US, right? So it is ultimately a choice made of where this can happen and on what lands it can happen on, right? Okay, you could do a variety of other things. You could be careful with turning off nighttime lights. You can reduce flaring. So there were large efforts being put in place by the Biden administration, which are now mostly being rolled back, but focused on putting pretty strict regulations on oil companies' ability to flare oil and gas. So gas is valuable. If you can store it and pump it, we use it to heat our homes and stuff. And so it's better to capture it and use it to heat our homes than just to burn it there wastefully at the drilling site. And so if you put a little impetus on companies to put more effort into reducing flaring, it's like we capture a valuable resource, the natural gas that we can use in our homes, and you reduce those local environmental impacts. So that seems like a win-win. And of course, ultimately, this problem is not going to be solved until you reduce oil and gas extraction by transitioning away from fossil fuels, right? So that's a longer-term mitigation strategy in terms of wildlife impacts, right? So yeah, that's all I've got. That concludes. And I'm happy for any questions. Yeah.
Thank you so much for that fascinating talk. Due to our aging circumstances here, we would ask that people stand up and ask their questions from the audience. And then for the sake of the folks on Zoom, Erik will need to repeat the question. So fire away.
You see a little bit about this because you have only impact considered for the winter. There's only 5 different sources of depth of birds in the fracking. Just because you don't know what the turbines have still died elsewhere doesn't mean it isn't happening. Also, it would be like contributing only death to suffocation by methane. So I'm a little unequal representation. Can you justify this?
Sure. So to try to reiterate the question, basically like, is it reasonable or fair to compare these two very different activities, these two very different types of impacts, fracking and wind turbines, right? They, like I point out here, they have all these different mechanisms. Can I draw comparisons between the two? And you also suggest another question about, can we attribute these impacts to sort of a specific cause of death or of impact, if I framed that correctly. So I think, of course, intrinsically, it's hard to compare very different types of activities, but again, using the same statistical approach and the same data set, I feel like the fact that I show significant negative effects of one and no measurable effects of the other, I can't say that one causes 10 times more impact than the other. Something like that I think is difficult, but I think I can conclude that one has measurable impacts and the other does not, right? So fracking has measurable impacts. Now, can I say that fracking is affecting things through methane emissions? No, I don't know. It says nothing. It's silent on what exactly is going on. Like I've mentioned, I think there's a whole variety of environmental impacts. There's light, there's flaring, there's noise, there's dust from truck traffic. All of those are potential contributors. And I think this is really where literature more focused on these case studies and on field work, right, rather than data analysis from ecologists and from people looking at these things could really fill in these gaps of trying to understand what is it about fracking that would be driving these. And some of the literature I cited really points to the constant truck traffic and resulting dust emissions as one of the main factors. But so in terms of the turbines, if a bird, well, let me think. Yeah. So I guess a concern you have is that if birds are impacted locally, but they fly away in somewhere else, you have to think like what's happening on the day of the count. So when people go out there to count and turbines are there, they're still seeing the same number of birds as they were before the turbines were built. I guess that's one way to put it.
Are able to determine how many are killed by the turbine, they're not being picked up from the branch field. They're only being picked up under the field.
So again, it's a question about. Well, no. So the question is where's the data being collected from? So there's about 3,000 bird circles, okay, and many of them never get. So about 85% of them never get a turbine. Those are serving as like a control group, okay. So those are places that never get this treatment of getting a wind turbine. Then there's also places that get a turbine in 2010, and so they're observed. There's a bird census every year before 2010. Where we're seeing the pre-treatment, right? We're seeing before this intervention happened in this circle, there were 10 years observed with, we see the number of birds counted in those 10 years in that exact same place. And then we see potentially a change in birds after turbines are built. And specifically for wind, there is no measurable change after the turbines are built. Yeah. Yes.
Appreciate the talk. Could you go back to the slide you had with the climate routine? I think you were describing a system. I'm just curious because I'm looking at the top left graph. I'm saying there's almost one, maybe 0 or 11.
No, not specifically. So I think Oh, okay. So the question here is about these time evolution graphs. And trying to understand, these patterns of why would certain years be looking a bit anomalous? Why, particularly for that top left one, it seems like there's negative effects for several years, and then it kind of comes back up a little bit. So I would say that the bird data is intrinsically a somewhat noisy data set. Okay, so it involves people going out in this big circle in a specific day in the winter and counting how many birds they see. And so that occurs with some noise. Right, and of course, people are also fallible, and they make estimates like, oh, I think I saw 500 red-winged blackbirds or something like that, right? And so it's not a data set that's collected with perfect precision and accuracy, and so that's why you see things bounce around in some noise. It could be that there's something actually going on, and maybe things are recovering a bit in those places, right? Maybe you have the impacts of the construction stage fading away. Actually, maybe in that point in time, this would be purely speculation, but fracking wells don't last that long. So they're depleted, 4, 5, 6 years, they might be depleted. And so it could be that production is wearing off a little bit in those places. That would be speculation. Both are pretty quick. Actual construction phase for both is probably about a year, 2 years max.
And then just a quick comment. Asia has 3.6.
Yes.
Yeah, I mean, it's a quick comment. I think, you know, if you think about this at scale, with 60 to 80 gigawatts of new gas field projected in the US, I would suggest raising that number at development scale. So
Yeah.
3.6 birds per well drilled on single page. What would potentially resonate more in my head on? Because I think that's how you started the time.
Yeah.
Is what that is on an annual basis across all of the projected oil and gas.
Yeah. Yeah. So that comment is that, you know, if we think that there's 3.6 fewer birds seen due to a fracking well being drilled. But what really matters is the fact if we're drilling 50,000 fracking wells, and this is the number of birds seen on a specific day, what does that mean for the reduction in birds that would be seen nationally because of our massive scale up of fracking? So that's an excellent point. In terms of the framing, I think that would be a lot more understandable than this, because people have no idea how many fracking wells are being drilled. In fact, it's a lot. It's, you know, tens and tens of thousands of them, right? An interesting fact, this is unrelated, but you reminded me of an interesting fact. Because of fracking, the US is by far now the largest oil and gas producer in the history of the world, of any country ever, right now, today. Maybe not today, but currently and within this month, right? So this has transformed the US into a major energy producer. It's been very successful in that sense, right? In terms of energy production, right? But of course, it also, if you think about that, affects the relative incentives of a country and how much incentive there is to transition away from fossil fuels if it's becoming such a big economic sector. Yeah. Thank you.
Get the data, like if somebody walked by around the wind turbines and how did you find that the numbers that somebody walked on those fields?
So there's two data sources, right? So the first data source is about birds, and this is collected, you know, annually in each of these circles by teams of volunteers, so citizen scientists who go out and collect data about all of the birds, right? And now, sorry if I didn't rephrase the question, it's where did these two data sets actually come from, which is interesting and important, right? So the birds data is collected by people, by volunteers who go out, and like I said, of course, they're fallible, right? So these are estimates. People are trying their best to tally up the number and species that they see. Praise to the data source, the Audubon Society's data on the Christmas bird count is amazing data. It's super high quality. It's really well organized, great to work with. It was really a pleasure, much more easy to work with this than like a lot of most government agencies that you interact with. A pleasure to work with their data. These data sets are, so the top is provided by a company called Rystad Energy. It's a Norwegian company that sells data to the oil and gas industry. So basically they have information collected from mostly government sources on where like I said, most of these are happening on public land. So the government has exact records of what's happening in each of these fracking wells.
So somebody walks on their way with this.
No, not the bird count. So that's collected from this bird census, right? And then on a separate data set is the location of all of these, but you can combine the two. So you can imagine laying one on top of the other and say, you know, because I know the location of each bird circle and I know the location of each fracking well, sometimes those coincide. And then you can see like this circle is affected by local fracking activity. And the same for the wind turbines. It's a government registry. Every wind turbine in the country, their exact location on the map is recorded in this database.
I guess what I'm saying, because I don't think that normal people can walk where the wind turbines.
You're correct. So in terms of that's actually a good, so the question is, how do they do the Christmas bird count around a fracking well? Because there's a fence around it and you can't go there. So you are 100% correct. They are walking within the circle, the same circle that they've always walked in, but they are not literally going into the fracking area. So theoretically, if there were tons of birds hiding in that fenced area with the fracking well, and the people didn't see them, that would confound my results. That would be a threat to my strategy, my methodology here, right? I don't think that is probably happening, but that you are correct that they probably are not counting inside that precise area. That's a good point. Yeah. No, it's a great point.
Really fast.
Thank you so much. Thank you.
Human activity around fracking, wind farms, has some effect on the environment. For instance, fracking, you mentioned the water that they use, that's extracted from the aquifer, just like farming.
Yep.
And I read an article that 20 of the top 40 cities, the largest cities, are experiencing subsiding.
Yes, I just saw that. Yeah.
Extraction of water. And you also mentioned the chemicals given off, but nobody mentions about the effect on the decreasing number of insects in the environment. And birds depend on insects also. And then the greatest genius, the eagle of our century, has said that offshore wind make the whales go crazy.
Yep. So I can comment on that. So the question is, like, birds are one thing that could be affected, but insects could as well. And offshore wind could theoretically affect whales, right? So birds are often studied as like an indicator species or like a bellwether species, right? So like it's the canary in the coal mine. So birds, if bird health is really struggling, probably it's safe to assume that insect health might be struggling as well, right? So birds are nice because people love birds, and so therefore they like collect lots of data on birds, right? And so like we can think how much effort we put into counting birds rather than insects. And so because of that, it's useful to look at birds, but it's probably correlated. And I think, we could safely assume that these effects are maybe similar for amphibians, reptiles, insects, and all sorts of other things. I think that's a very safe assumption. Yes, people raise a lot of issues about offshore wind affecting whales. There's literature about this topic. People who have studied offshore wind farms find that the wind farm installations create local habitat, and you actually see a lot of abundance of fish and marine like mollusks and things, because it's like creating like a microhabitat for them. So you actually see an increase in abundance and an increase in some birds. You also see some bird avoidance of certain species that seem to like avoid those areas. The part about whales is mostly misinformation. I think there's not a lot of credible evidence about the whales being really negatively. Whales are severely negatively impacted by ships. When the ships are a massively 100 times larger impact than wind turbines. And I'll also point out that down here in the Gulf of Mexico, there's thousands and thousands of oil and gas offshore platforms, right? So that's not counted here, that's not fracking, right? And a lot of these platforms are older, a lot of them are abandoned, they're just rusting there. And those, and again, in an offshore oil platform, it's not just a wind turbine kind of turning silently, it's like constant, gas turbines, and there's a lot of undersea disruption. So it's kind of the same thing. We're not looking at it here, but like there's a trade-off as well between offshore wind and offshore oil and gas. And so again, there's no reason to think that an offshore wind turbine, if it affected whales, which there's no evidence that it really does, it would have worse impacts than the massive amount of offshore oil and gas platforms that we're using. Right? It's a great question because it's in the news right now. Yeah. Yes. It's a great question. So the first part of your question was, I just blanked, so remind me real quick.
It was.
Exactly. So thank you. So first of all, could you do this with other sectors? And the second question is about thinking about, are there some characteristics of turbines or fracking that you could look into to see like really which factors are mattering the most? So the first question, I thought about doing it for solar. So the US government, just like it has this database of all of the wind turbines, it has an exact same database of all the utility scale solar installations. So that's like the kind you see out in the field. There's just not much literature about that affecting birds. It could, definitely, and it would have been trivial to do it. Maybe I should have. It would have been the exact same thing. You don't see many people talking about it, right? Because maybe I guess it's less likely to count the collision deaths because it's not like a big tall structure. You could have looked at it for buildings, right? So there's data about buildings getting built, and so I'm sure if you did this with buildings like in an area that's getting more and more urban, or either like literal buildings going up or urban expansion, like land use change towards urbanization. You could do the exact same methodology and look at the results. The urban thing might get a little strange because that might increase some bird types. But again, you might pick that up in the urban versus non-urban. You might see more pigeons and sparrows and things like that, and less owls, you know. So you could totally do it, and it would be quite interesting to do it with a whole variety of other things. About your second question about, well, are there factors that influence things? So first of all, for the wind turbines, I don't find any effects overall. So I don't, you know, I didn't really look into it further, but that database here, it tells you interesting things. So over time, wind turbines keep getting taller and taller, and their blades keep getting bigger and bigger. And that's basically because I guess the physics works out that the bigger it is, the more cost-effective and efficient it is. They keep trying. The constraint is that it's harder to get a bigger and bigger thing out to the field. Once you build it somewhere, you have to get it out there, and that becomes increasingly difficult. But so you could wonder if these things are getting bigger and bigger, the big bladed ones might impact birds more than the small ones, right? So if you look at one built in 2020, in like 2000, 2005, it might be like, you know, 4 stories tall, 5 stories tall. The current ones being installed might be like 40 stories tall. They're getting massive, right? And so it could be, and you could split up the sample, and you could look big turbine, small turbine, something like that. There's not data about whether they're doing the painting because I don't think that's been implemented at scale. Like I said, there's been small studies that found that to be really effective in reducing collision deaths in like case studies. So that would be super cool to look into. Another thing that was on the last slide is there is concern about bats, right? Bats are super important. They're another species that matter a lot, huge, you know, pollinators, insects and stuff. What was it? Bats might be more negatively impacted by wind turbines than birds. Part of that is because as the turbines rotate, they're generating sort of acoustic sonar type things that we don't maybe pick up on, but it kind of might even attract the bats to it, and then they collide, and anyway, or it hurts their echolocation. So there is some literature about that. There's not massive systematic citizen science collection of data on bats. They're out at night, hard to count them. There is some concern there about bats, and like there's research going into acoustic emitters that could like cancel out the natural signature of the wind turbine to stop attracting the bats, or maybe something that would like deter them or let them know that that's, you know, an area they would avoid. Yeah.
Based on your first proposition, that this started around media, and how you all this you found really interesting data. And is it moving the needle? Is this going to be picked up, or what do you think is really going to happen?
That's a good question. So the question is, okay, you do this research, then does this affect anything, right? Like, could this move the needle? Could this inform public debate? I really hope it informs public debate. I hope that this can provide some empirical evidence to contribute to discussions that often are based on not empirical evidence, right? So I hope so. I would say that it's moved. I think it's, I've been super happy. Like I said, most of my research is about economic stuff. And I wrote this paper because I kind of love birds. And this paper has like gotten way more traction than anything else I did. So it's been written about in The Economist and the Los Angeles Times and like a variety of media sources. It shows up in several Wikipedia pages now about wind turbines. You know, so this is hopefully providing a data point, like some empirical evidence to inform this, I hope. I think that the Trump administration is not basing their decisions on empirical evidence mostly. So I don't think it's going to affect that. But who knows? Maybe, you know. But I hope so. I hope so. And the more that people like are informed about these topics, you know, for example, let me go back right to like, this is not about birds, but I wish everyone could just like learn this graph. I feel like if everyone just memorized this graph, it would inform and elevate a lot of public debates, right? Another graph I should have showed, but I didn't, so this is showing, you know, relative health impacts and climate change impacts. A graph I should have showed is the relative costs of different energy sources. So I'm teaching a class right now for undergrads about the energy transition. And one of the things I keep telling them, because maybe people are feeling a bit depressed or a bit down about current events, right? And something I keep telling them is like, look, the technological change of renewable sectors, the fact that they're falling in cost year on year, so solar and wind and batteries are falling in cost year on year so quickly that they are becoming really compelling energy sources, no matter whether you care about climate change, whether you believe in climate change or not. Currently, onshore wind and utility scale solar are the cheapest forms of energy that we can build as society. They're also the only things you can build short term. So it takes right now, if you wanted to build a gas power plant, it would take 5 to 10 years because there's a huge backlog because all of the data centers are buying the gas turbines. So you can't build new gas turbines right now. Nuclear takes at least 10 years and comes in super expensive. So nuclear has some benefits, right? Very clean, stable flow, massive power output, takes a long time to build and is pretty high price point. Wind and solar are the cheapest. Even if you add batteries, they're the cheapest and they're falling 30 to 40% per year. So they're becoming really valuable energy sources. And something that tells you how just it cuts across the political spectrum is that, where were my maps? That Texas and Iowa are two of the biggest renewable energy adopters in the country right now, right? So Texas is building massive amounts of wind and solar, and Iowa's building massive amounts of wind. And it's interesting, right? So it has nothing to do with politics. It has to do with these are really compelling energy sources, right? So they're the cheapest options. And so I think ultimately that will maybe win out. And if political leaders try to block that from happening, they can do that temporarily and the rest of the world will move on and there'll be a wedge opening up between cheap energy in other places and expensive energy here. And at some point that'll give as incentives become clear enough that renewable energy sources are really compelling. Yeah. That's a good question. So yeah, there were several papers about Norway that they were really looking at these bird impacts and where they're siting their turbines, to minimize bird impacts. China is leading the world right now in terms of renewable energy expansion. So like China in the past year built more solar energy than the US has in its total history, right? So the scale of the speed and the scale of the change at which China is installing renewable energy is shocking. And that's great, right? They're also building coal power plants, so they're building everything, and so it's a mixed bag. But they're also leading the world in terms of exporting solar panels and things like that. So super cheap. So that price fall, that drastic, huge fall in batteries and solar panels and things that you're seeing is because they're being made in China. And so a lot of countries are there's like a revolution happening in a lot of countries of people adopting solar, for example, and whole countries that didn't have reliable electricity before are suddenly, maybe your government for 20 years has given you unreliable, bad power grid, and you're fed up, and you just go online and, order for online delivery some solar panels from China, install it in your village or for your factory. Maybe they even send a technician out to install it for you. And it's really rapidly transforming big parts of the world. So I have no idea how that affects birds. I don't know about any research looking at that in other countries. That would really be driven by data sources. So eBirds collected all over the world. I just read a paper that uses eBird in India and to look at other things, not wind turbines. So people use those data sets all over, right? And so you could presumably, we should think about that sort of research in other places. Yeah, because there's a lot of renewable energy stuff happening in other places. Yeah. Yeah.
Are there studies restricted to populous areas
I don't know about that. So I'm not an expert on that. So the question was about cats. So going back to, if we think it's 1 billion birds, I have no idea if that billion is reasonable or not. Like that seems like a round number, right? It seems like a sort of an approximation, but that's like, we think that's a really big impact on probably more on urban birds, I would assume, right? Most cats are probably in urban areas. Someone here might know more about cat impacts than I do. So yeah, I'm not an expert on the topic, but I have seen, I have, you see cats grab birds and it's always kind of sad. Yeah. See if there's anyone who hasn't asked, otherwise, yes, go ahead.
There are also spiral wind power that capture air closer to the ground. As a matter of fact, the Whole Foods out in Brooklyn has some.
So the question is about spiral wind turbines, which exist, and I have no idea if they would be maybe better for birds. I don't know exactly what particularly about the big rotating turbine this way affects things. I don't know, so it's a great question. They're not really being done commercially at scale, and I don't know why. But so I assume the industry has concluded that the other ones are either cheaper to build or generate more electricity, because you're mostly seeing, you know, the standard type of format. But that's yeah, I have seen these ones as well. I think there's a question.
Would it put them on any sort of much of the wealth of that including kudos to them for having it now and having those things sort of promote the child.
Okay, so there's a comment about Norway has built its wealth on oil and gas extraction. And so Norway is an issue. So when I was in Switzerland, I worked a lot with some people in Norway because I work on things about oil and gas, and so they do a bunch of that stuff, right? Because they have a big industry. So the Norwegians are interesting. It's like it's the most electrified country in the world. Like they basically have tons of hydropower as well. They're acting as like a big battery right now because they have a bunch of hydropower up in their mountains, and they have a big interconnection with the United Kingdom. And so when the wind is not blowing in the UK, they import Norwegian hydropower. And when there's too much wind blowing in the UK, they ship the electricity back to Norway and they pump the water back up into the mountains to store it. It's like a giant battery. So that's cool. The oil and gas, they have a funny way of thinking about it in Norway, where they really want to convince you that you should count pollution at the place where the oil is burned, not where it's produced. So if you do that, Norway is like the cleanest country in the world because they don't burn the oil, right? They're driving EVs and stuff and they export it all to make money. And so it's burned somewhere else, and that means Norway super clean. But if you count it where it's produced, well, then Norway per capita is super, super dirty country. So yes, point taken. Yes, yes.
Erik, there are two questions in the chat. I don't know if you would be able to pull them up here, or I can show you because they're a little long, so I can't really give them to you.
Repeat them. What would be easier?
Can you just speak into here?
I'm sorry?
Can you speak into this?
Is it
Can you speak into the microphone there?
Oh, I'm just saying there are two questions in the chat because they're long. Well, if I speak in here, okay, people will be able to hear that on Zoom.
I think it might be here. Let's see.
Got it. Sorry. Like this? Is this okay? All right. One moment. You know what? I can read them and people on Zoom will hear. So first is Nancy saying, I live in Vermont. On Christmas bird count day, there may or may not be significant snowfall on the ground, which will limit the routes of the field counts. So we do not cover the same route every year. You may correct snowfall on the day of the count, but the accumulated snowfall from all the week before also affects how we can count. So it's more a statement than a question, but perhaps you have a comment.
Thank you. So that's actually a really great question. I completely agree. So what I can do is control, like I mentioned, control for all those weather factors. But that does not control for the fact that there might be a lot of accumulated snowfall. A cool thing about the Christmas bird count is they also,
I might be getting an echo. Is there?
Yeah.
Sure.
Okay. There we go. Thank you. It is actually reported how much of the count is done on foot, on cars, at bird feeders, by ski, snowmobile, and things, a boat, and things like that. And so that I don't adjust for that, but you could, and that would maybe account for the fact that there's a bunch of snow. You might be using different modalities to do the count. That's a great point.
Okay, the other question is, I apologize if you addressed this. You are using Christmas count data, which will have lower abundance and lower diversity built in. But also, our wind turbines use less in winter. Couldn't either of these or both together skew the statistical impact of bird mortality?
That's a really nice question. Okay. Let's see. Okay, that's fine. So the, so, okay, could winter affect, like, what was the first part of the question there was, oh, the count, okay, if this count is less in the winter. Okay, so, yeah, so of course, like we're seeing a strange type of year for the bird count. Actually, maybe someone knows the history of why it's a Christmas bird count. I don't know that. I know there's others, right? There's the North American Breeding Bird Survey is another one I considered using. That's sampled at breeding times, and so it's a lot more birds in the sample. The problem with the breeding bird survey is it uses very small transects for the survey, and those just don't intersect enough with the areas with oil and gas and with wind turbines to be able to measure anything. So that's why I didn't use that. A limitation of the Christmas bird count is, yeah, you're getting a day in December, and so you could maybe it's safe to assume that whatever impacts I'm finding here would be amplified to a proportional degree when there's a lot more birds around. So a negative impact in the winter of this much might be this much in the summer if it has the same type of impacts, right? Wind turbines, depending on the location, often are operating more in the winter than in the summer. It's hotter in the summer, and therefore sometimes that heat and that humidity are slowing the wind. You can think of like stagnant hot days, and often in the winter you have cold, windy days. And so if anything, they're turning more in the winter during this count than they would in the summer. That would suggest that you couldn't just extrapolate these effects by, scale them by the number of birds in the summer. There could be different effects throughout the year, and it's not able to be measured here. It's just a once a year count. Those are really nice questions. Thank you.
Well, thank you for an utterly fascinating talk. You treated us to an utterly fascinating talk, and you left us with a note of optimism, which is a very hard feat in this time. So
Yes,
thank
happy
you,
to do
Erik.
that. Yes.
It was really
Thank you so much.
delightful.
Yes. Thank you, everyone.